So may I start, please? Can you see my screen?
Yes, sir.
So today we are going to see the third chapter of this paper number 15th. The title of the paper you are already knowing that it is the classical and quantum mechanics. So far we have completed two chapters. One chapter we have already covered, that is the classical mechanics, and the second chapter was origin of the quantum mechanics. In the beginning of this particular chapter or particular section of the quantum mechanics, I have already told you that what is the definition of quantum mechanics, what is the difference between the classical and quantum mechanics. All these things we have seen in the last period, isn't it? Now, in the continuation of the first chapter, origin of the quantum mechanics, the second chapter is particle duality, or its title is wave particle duality. From the name, it is very much clear that what do you mean by duality? Can you tell me what is duality? दोहरापन, isn't it? Double standard जिसको बोलते ना हम, that is called as duality. Now, waves we are knowing. So first of all, I would like to share with you that what are the articles that we have to cover in this particular chapter. De Broglie's hypothesis of matter wave, then its wavelength in terms of energy and temperature, de Broglie's velocity and particle velocity. Then we have to see what is the definition of group velocity and phase velocity. Then we will throw the light on the Davis and Germer experiment. Then we will see the Heisenberg uncertainty principle. Then we will see the application of Heisenberg uncertainty principle. And the most important focusing article of this particular chapter is the uncertainty principle, isn't it? So now here today, we will go to the, in this particular article lecture today, just we will try to cover these three articles. First of all, we will see that what we are going to see is the introduction. Then we will go to the de Broglie's hypothesis of the matter waves. Then we will see the de Broglie's wavelength in terms of energy and temperature. And at last, I will conclude the lecture by giving the summary of this particular lecture today. Now, nature of the particle. You know, particle. Are you knowing? Anybody of you can please unmute and tell me, do you know particle? Please tell me. Afifa, can you tell me what is particle? All of you are there? Particle is specified by mass, its velocity, isn't it? V and momentum P and energy E. The particle occupies the definite position in space, as you are knowing, isn't it? In order that it must be a small. Now you know light. Do you know what is light? Can you tell me? All of you are getting me, please? Madia, Afifa, Nishat, Anam, all of you are getting me, please?
Yes, sir.
Are you getting?
Yes, sir.
Do you know what is matter? What is matter? Light, a matter. Sound, it is a matter, isn't it? So if you, for example, light, if you consider, You know that light, it is made up of particle, light's corpuscular, Newton's corpuscular theory we have seen, isn't it? We have also seen the different phenomenon which explain that light is in form of wave, that is Huygens principle we are knowing, isn't it? लाइट क्या है? मैटर का हिस्सा है. साउंड क्या है? मैटर का हिस्सा है. लाइट पार्टिकल की शक्ल में भी रहती और ये वेव की शक्ल में भी रहती. दैट मीन्स मैटर possess the dual nature. Some properties of the light or some property of the matter are that of particle, and some properties are that of wave. That means it behaves dually. It has dual nature. Sometimes it behaves like a particle, sometimes it behaves like a wave. Are you getting, please? All of you, please tell me. Unmute yourself and tell me whether you are getting or not. समझ रहे हैं आप?
Yes,
आप समझ
sir.
रहे हैं, प्लीज? So, what is light? Now, in case of light, we have seen these two phenomena, interference and diffraction. These two phenomena light possess, or these two phenomena are satisfied by the light. That means from these two phenomena, it was confirmed that light is in form of wave. Regarding the nature of the light in the beginning, that means in the 16th century, the scientist Newton has given his theory, and that theory explained that light is in form of particle, and that theory was called as Newton's corpuscular theory. Do you heard this name somewhere? Please, anybody or all of you unmute and tell me yes or no, so that I can understand that you are listening me. Please, all of you. समझ रहे हैं आप?
Yes, sir.
यानी कि इंटरफेरेंस और डायफ्रैक्शन, ये दो फेनोमेना लाइट ओबे करती, ये इस बात को जाहिर करता है कि लाइट कौन सी शक्ल में है? वेव की शक्ल में है. और पर्टिकुलरली डायफ्रैक्शन, ये फेनोमेना तो प्योरली किसके लिए है? जो मटेरियल या जो मैटर वेव की शक्ल में रहता है, मौज की शक्ल में रहता है, उसका ही डायफ्रैक्शन होता है, isn't it? And that means light, it obey the diffraction, or it satisfied the diffraction phenomenon, means light is in form of wave. On the other hand, if you consider the black body radiation in the previous article or in the previous chapter we have seen, and the photoelectric effect we have also seen in second year, or also we have seen some part of it in the first chapter, explained only by considering light as a stream of particle. That means in these two cases, if you consider the light as a matter, we found that up till now we have seen the 4 to 5 different phenomena which light obey. In out of these 4 phenomena, 2 phenomena are explaining that, are showing us that matter is in form of particle and our light is in form of particle, while remaining to explain us that matter is in form of the wave. That means from this we conclude that matter is in form of particle as well as it is in form of the wave. That means matter possesses the dual nature. It is present in form of the wave as well as it is present in form of the particle. It is regarding the light only for time being, isn't it? But how they are related? We know E is equals to h nu. We have seen in the previous lecture or in the previous chapter that the energy associated with this wave, it is given by E is equals to h nu, where h is the Planck's constant, nu is the frequency of the wave which it is flowing or it is moving. And from this one we can also write P is equals to h upon lambda. That means when it is a wave and when it is moving, it possesses the momentum also, because for the momentum it is necessary that there should be a mass, there should be a velocity, and we know that the wave it is moving, That means the particle it is moving, and that's why when it is moving, it has some velocity, and when it is in form of particle, it possesses the mass, and therefore mass into velocity, it is called as the momentum, and therefore it is for the wave or for the light wave, that should be a momentum. That momentum it is denoted by symbol P, and that momentum it is usually is given by the formula P is equals to h upon lambda, where h is once again Planck constant and lambda is the wavelength of the wave. Wavelength किसकी रहती? पार्टिकल की रहती क्या जी wavelength? Please tell me yes or no. पार्टिकल रखता क्या wavelength, क्या वेव रखती? Please unmute yourself and tell me.
Wave.
वेव है तो उसकी wavelength रहेंगी. So that means light it is in form of the wave, therefore it possesses the wavelength, and therefore it possesses the momentum. An expression for the momentum of the wave, it is given by the formula P is equals to h upon lambda, isn't it? And therefore P is the momentum of the particle. Now this particle is moving in form of the wave, therefore it possesses the wavelength, and that is given by P is equals to h upon lambda, isn't it? And therefore, after having seen the some observation of the light particularly, because light is one part of the matter, light किसका हिस्सा है? मैटर का हिस्सा है. मैटर बोले तो सब आता है उसमें, लाइट भी आएंगी, साउंड भी आएगा, और दीगर भी जो है तो वेव्स आएंगे, जो रस्सी के ऊपर, रोप के ऊपर जो वेव्स तैयार होते हैं वो भी वेव्स आएंगे, isn't it? But here, after having seen the different phenomenon of light, behavior of light, result of the different phenomenon of the light that was experienced by the light, the scientist Louis D. Broglie in 1924 had made his hypothesis, or explained his hypothesis, or given his hypothesis to the universe, or he's boldly suggested. कौन से साल में? in 1924, that क्या suggest किया उसने? that similar to light, dual nature, जैसा कि लाइट का dual nature है, UV moving matter has associated with the wave. That means what de Broglie has suggested, कि खाली लाइट ही जैसी नहीं है कि जो पार्टिकल का भी नेचर रखती और वेव का भी नेचर रखती, बल्कि बहुत सारे एक्सपेरिमेंट के बाद साइंटिस्ट डी ब्रॉगली ने या लुइस डी ब्रॉगली ने ये हाइपोथेसिस जो है लोगों के सामने रखा, ये नजरिया लोगों के सामने रखा कि एवरी मैटर, वेदर इट मे बी ए लाइट, whether it may be a sound, whether it may be any part of material or any matter, it behaves in form of particle as well as in form of the wave, that every matter possesses dual nature. Some properties of the matters, they are explaining the particle nature, and some property shows that matter is in form of the wave. And that's why this hypothesis, which was given by the scientist Louis de Broglie, is called as de Broglie hypothesis. क्या डी ब्रॉगली हाइपोथेसिस है? प्लीज टेल मी बाय एडमिटिंग योरसेल्फ. क्या है डी ब्रॉगली का हाइपोथेसिस? क्या है डी ब्रॉगली का नजरिया? किसके ताल्लुक से है? पहले तो the hypothesis of the de Broglie is regarding the matter, isn't it? और क्या नजरिया है? क्या हाइपोथेसिस है? The hypothesis is that matter possess dual nature. It is in form of particle as well as it is in form of wave. Have you understand, please? Tell me yes or no. Then
Yes,
I will
sir.
go. Have you got the idea? So this de Broglie's hypothesis is also very important from the examination. No doubt it is important from the examination point of view, but it is also important as far as the study of the quantum mechanics is concerned. Throughout the study of quantum mechanics, जहां तक क्वांटम मैकेनिक्स का ताल्लुक है, डी ब्रॉगली का हाइपोथेसिस बहुत इंपॉर्टेंट रोल प्ले करता है. The role of the de Broglie hypothesis is most important in the field of quantum mechanics. No doubt it is also important from the examination point of view. Many times in the examination, the question was asked on the de Broglie hypothesis, that state and explain the de Broglie's hypothesis with an example. Such type of question or the question may be asked in by alternating way, but this question was asked many times in the examination for 5 to 10 marks. So have you understand the de Broglie hypothesis? क्या hypothesis है कि matter possess which nature? Please.
Dual nature.
Dual nature. It is in form of particle as well as it is in form wave. Some properties or some phenomenon of the matter explain that matter is in form of the particle, while some phenomenon explain that matter is in form of the wave, and that's why it possesses the dual nature. That means matter, it is a particle of course. Light की बात करें हम अगर matter, तो light particle की है, लेकिन यही particle एक जगह से दूसरे जगह जाते वक्त किसकी शक्ल में जाएगा? ये सीधा नहीं जाएगा, बल्कि दिस पार्टिकल मूव्स इन फॉर्म ऑफ व्हाट?
Wave.
Wave. And that's why light is in possess the dual nature, isn't it? And if light acts like a wave, sometimes like a particle, then the other times it works as a form of particle. Light कभी जो है पार्टिकल की शक्ल में बिहेव करती, और लाइट कभी जो है तो वेव की शक्ल में बिहेव करती. Then in the similar manner all matters do. Usually the thought of as particle should exhibit the wave-like behavior, isn't it? And the relation between the momentum and wavelength of the photon can be applied to the material particle also. That means as in case of the light, we have applied the momentum किसकी रहती? Particle की रहती, क्योंकि उसको mass है, isn't it? And that's why we have taken the momentum p. But this ये momentum p वाला पार्टिकल ये जो है तो किसकी शक्ल में हरकत कर रहा? वेव की शक्ल में हरकत कर रहा, तो उसको क्या लगी रहेंगी? वेवलेंथ लगी रहेंगी. एंड दैट्स व्हाई दिस रिलेशन बिटवीन द मोमेंटम एंड वेवलेंथ ऑफ ए फोटॉन कैन बी अप्लाइड टू द मटेरियल पार्टिकल as in case of the light also, isn't it? Now graphically if I want to show you the dual particle duality, then see here पार्टिकल बोले तो ऐसी शक्ल का, और यही पार्टिकल एक जगह से दूसरी जगह जाते वक्त किसकी शक्ल में क्या दिख रहा है जी? ये कैन यू सी माय कर्सर प्लीज? आप मेरा कर्सर देख रहे हैं? क्या है ये? वेव है. किसकी बनी हुई रहती है जी वेव? क्या रहता है उसके अंदर? व्हाट इज दिस? Crest. And this is trough. That means the wave which is consist of alternate crest and trough, it is nothing but it is the behavior of particle. That particle is moving in form of the wave. It is consist of alternate crest and trough. That means it possesses the wavelength. And therefore this hypothesis regarding the matter was given by the scientist de Broglie. Therefore it is called as the de Broglie's hypothesis. डी ब्रॉगली हाइपोथेसिस ने पार्टिकल नेचर है ये तो पहले से बोला मालूम था, लेकिन वेव नेचर है ये भी कौन बताया? किसने बताया? कौन से साइंटिस्ट ने बताया कि पार्टिकल तो पार्टिकल की शक्ल में तो रहता, लेकिन साथ में वेव भी शक्ल का रहता, वेव भी इसके अंदर है. कौन बताया? व्हाट इज द नेम ऑफ दैट साइंटिस्ट? डी ब्रॉगली. डी ब्रॉगली. दैट मींस वेव का वजूद पार्टिकल के मैटर के अंदर है, ये डी ब्रॉगली ने बताया. इस वास्ते वो वेव को भी क्या नाम दिया गया? डी ब्रॉगली वेव. दैट वेव, दिस वेव इफ यू आई वांट टू सजेस्ट, इट इज द डी ब्रॉगली वेव. नाउ दिस वेव हैज द वेवलेंथ. आर यू एग्री विथ माय सजेशन दैट दिस वेव हैज द वेवलेंथ, इजंट इट? आर यू एग्री? जब वेव है तो उसके साथ क्या लगी है? वेवलेंथ लगी हुई है. लिहाजा दिस वेवलेंथ इज आल्सो कॉल्ड एज de Broglie's wavelength. This wavelength is called as de Broglie's wavelength, and it is denoted by this symbol, as you know, lambda. So hereafter when I will say wave, you should understand that it is de Broglie wave. When we will consider wavelength of a wave, that means you should remember that it is the de Broglie's wavelength, isn't it? Now de Broglie's wavelength, as in case of previous one, lambda, it is equal to h upon p, isn't it? Where h is what?
Planck's constant.
Planck's constant. And p is usual
Momentum.
Momentum किसकी रहती? पार्टिकल की. वेव, और वेव किसकी रहती? वेवलेंथ किसको लगी हुई रहती? पार्टिकल के साथ वेवलेंथ रहेंगी क्या खाली? किसके साथ रहेंगी वेवलेंथ जुड़ी हुई? किसका कंसेप्ट है वेवलेंथ? जब कोई मैटर पार्टिकल की शक्ल में है तो जब उसको वेवलेंथ रहती क्या? प्लीज टेल
वेव
मी।
की शक्ल में रहती
हाँ, वेव की शक्ल में, यानी
वेव
कि
को
yes, that means this equation lambda is equal to h upon p, yeah, lambda is equal to h upon mv. This relates the particle like property p to the wave like property lambda, isn't it? यानी कि this expression for the wavelength, that is the de Broglie's wavelength, is nothing but it is h upon p, relates the particle nature or the particle property, that is this momentum of the particle, and lambda wavelength, that is the wave like property. Have you understand? May I go further? चलूं आगे please?
जी सर।
Yes. Now de Broglie's wavelength, just I have explained you that the wave nature was explained by the de Broglie, therefore it is called as the de Broglie's wave, and the wavelength of the de Broglie wave is also called as the de Broglie's wavelength. The wave associated with the matter particle is called as the matter wave, isn't it? And the wavelength associated is called as the de Broglie's wavelength, and it is denoted by the symbol lambda. Now, this photon will travels with the velocity c, that is the velocity of light, and we can express this momentum p is equal to E upon c, we know. But E is what? Energy. Energy इसका फार्मूला क्या है जी? क्या हमने पहले बोले कि फोटोन, हमने फोटो इलेक्ट्रिक इफेक्ट में देखा, हमने गुज़िश्ता चैप्टर में देखा कि जो एनर्जी लगी रहती फोटोन के साथ वो कितनी है? E is equals to
h
nu. Therefore, may I write this equation for momentum like this? P is equal to h nu upon c. Is it possible for me? If yes, then can I write this h nu upon c as a h upon lambda? Because c nu upon c, because c upon nu is equals to lambda, है क्या नहीं? ये यश तो कांस्टेंट है, लेकिन न्यू अपॉन सी, न्यू क्या है? फ्रीक्वेंसी है, सी क्या है? वेलोसिटी है, और इसका एक्सप्रेशन आपको मालूम है कि सी अपॉन लैम्बडा, न्यू इज इक्वल्स टू लैम्बडा. देयरफॉर इन दिस केस h as it is and nu by c के जगह पे 1 upon lambda, and therefore lambda we know h upon p, but here p is equal to h upon lambda. So as the particle of mass m moving with the velocity v carries the momentum p. फर्ज कीजिए कि एक पार्टिकल है, उसकी मास m है, वो हरकत कर रहा है, when it is moving it possesses the momentum. Suppose that momentum is p and the momentum is given by mv, that is mass into velocity, and it must be associated with the wavelength, that is lambda, and that lambda should be equal to h upon mv, and therefore this equation lambda, what is this lambda please? Please explain me, all of you please unmute yourself. वेवलेंथ, कौन सी वेवलेंथ? क्या कहलाएंगी कौन सी वेवलेंथ?
डी ब्रोगली वेव,
डी ब्रॉगली वेवलेंथ इज इक्वल टू क्या? h प्लैंक्स कांस्टेंट अपॉन
momentum
mv, and this relation is known as de Broglie's equation. Lambda is equal to h upon mv, this equation, यानी कि this is the expression for the wavelength of the de Broglie's wave, is nothing but it is called as de Broglie's equation, and the wavelength lambda is known as de Broglie's wavelength. If in the examination, if it is asked, explain the de Broglie's hypothesis and derive the expression for it, ऐसा अगर question आया तो you have to write since from the beginning to this equation. Or the question is that explain the de Broglie's hypothesis, state the de Broglie's hypothesis and derive the expression for de Broglie's equation. Yeah, give the de Broglie's equation. Yeah, derive the de Broglie's equation. Then you had to write the answer of that particular question up to this point. Have you understand de Broglie's hypothesis and expression for the de Broglie's wavelength? Please tell me yes or no. Then I will move further.
Yes.
So may I go ahead? चलूं आगे?
Yes.
Yes, de Broglie's wave associated with an accelerated particle. Now, just we have seen that the particle is there, this particle is moving in form of the wave, therefore it possesses the wavelength, isn't it? And now there are the different types of particles, charged particle रहते हैं, accelerated particles रहते हैं. Suppose a particle is there, suppose a charged particle के तौर पर किसको कंसीडर करना जी? पार्टिकल समझता आपको सेकंड ईयर में हो गया, पार्टिकल पढ़े आपको ने बहुत सारे. कौन कौन है पार्टिकल? Electron is particle, proton is particle, neutron is particle, biotron is particle, isn't it? All these are the particles. Are you agree with this one? उसमें चार्ज पार्टिकल कौन से है? जिनको चार्ज लगा रहता, मिसाल के तौर पर सपोज इलेक्ट्रॉन, isn't it? If a charged particle, say an electron, is accelerated by the potential difference of p volt, that means potential difference का फोटोइलेक्ट्रिक इफेक्ट है. इधर एक इलेक्ट्रोड है, इधर एक इलेक्ट्रोड है, एक कैथोड है, एक एनोड है, एक पॉजिटिवली चार्ज है और एक निगेटिवली चार्ज है. इसका मतलब दोनों पोटेंशियल के दरमियान क्या है? पोटेंशियल डिफरेंस है. तो ये दोनों के बीच में कौन फिरता? इलेक्ट्रॉन चार्ज पार्टिकल है, कैथोड से निकलता और किधर जाता, या एनोड से निकलता कैथोड में जाता है कि नहीं? पॉजिटिव इलेक्ट्रोड से निकलेगा, निगेटिव से निकलेगा, पॉजिटिव की तरफ जाएगा. तो सपोज दैट there is a charge particle, that is electron, and it is accelerated. कब accelerated होता है? Because when there is a potential difference v, isn't it? And then it produces the kinetic energy. क्योंकि उन्हें हरकत में है. जब चार्ज हो गए एक इलेक्ट्रोड से दूसरे इलेक्ट्रोड की तरफ जाता तो उन्हें हरकत में रहता कि साकिन रहता जी. When the particle is going from one electrode, suppose for example anode to cathode, whether it is in form of it is at rest or it is in motion,
Motion.
it is in motion. When it is in motion, it possesses the kinetic energy. Are you agree with this fact? And therefore that kinetic energy E is suppose there, and it is given by EV. When it is in the electric field, जब इलेक्ट्रिक फील्ड रहेंगी ना, पॉजिटिव और निगेटिव पोटेंशियल रहेगा, लिहाजा इलेक्ट्रॉन को कौन सी फील्ड दी जाएगी? इलेक्ट्रिक फील्ड दी जाएगी, और वही उसकी एनर्जी होगी. यानी कि एनर्जी इज इक्वल्स टू ईवी, एंड दैट इज द काइनेटिक एनर्जी, इट इज 1/2 mv square. And therefore we can write P is equals to under root, if from this equation, 2 into EV upon m, isn't it? And then electron wavelength, if you want to, because this electron is moving between two electrodes in form of, अभी बोले in form of, कैसा चल रहा? सीधा क्या?
No.
In form of
Wave
wave.
की शक्ल
जब
में.
it is in form of wave, it possesses the wavelength, isn't it? जब ये वेव की शक्ल में जा रहा है, इसका मतलब इसको क्या लगी हुई रहेंगी? Wavelength. And therefore that lambda is the wavelength, and it is given by lambda is equal to h upon m. We have seen. Therefore h upon m as it is, v के जगह पे ये पूरा, ये डिनोमिनेटर में इस वास्ते ऐसा लिख सकते हैं कि इसको अंडर रूट m upon 2ev. Can you understand this equation please? Please tell me yes or no. समझ में आया?
Yes, sir.
And therefore lambda is equal to h upon under root 2m. इस इक्वेशन लिख सकते हैं mev. This is the required expression for the wavelength of the de Broglie's wave in terms of energy. अगर एग्जाम में पूछता है कि ड्राइव द एक्सप्रेशन ऑफ द de Broglie's wave in terms of energy, तो then at that time lambda is equal to h, Planck's constant, under root 2 mev. It is the expression for the wavelength of the de Broglie's wave in terms of what? EV is what? यस तो कांस्टेंट है, यम भी कांस्टेंट है, ईवी क्या है जी? क्या है ईवी? एनर्जी. दैट इज द एक्सप्रेशन फॉर द वेवलेंथ इन टर्म्स ऑफ एनर्जी. डी ब्रॉगलीज वेवलेंथ इन टर्म्स ऑफ एनर्जी एंड टेम्परेचर अगर हम बात करें तो जस्ट आई हैव टोल्ड यू दैट काइनेटिक एनर्जी इज इक्वल टू 1/2 mv स्क्वायर. इसका अगर हमने यम से मल्टीप्लाई करके अगर डिवाइड करें तो इट इज यम स्क्वायर वी स्क्वायर अपॉन 2m. Therefore numerator is क्या है जी? mv बोले तो क्या? What is mv? Please tell me immediately.
Momentum.
Momentum. तो ऊपर वाले को न्यूमरेटर को ऐसा लिखोगे p स्क्वायर अपॉन 2m. एंड therefore ये मोमेंटम अगर है तो मोमेंटम p स्क्वायर इज इक्वल टू 2m into kinetic energy. Therefore p is equal to under root 2m kinetic energy. Therefore lambda is equal to h upon p. Therefore once again lambda is equal to h upon under root 2m into kinetic energy. This is the of the de Broglie's wavelength in terms of what? क्या के टर्म में de Broglie's
Energy.
energy. If the particle is in thermal equilibrium, that means that particle which is moving, it is also having some temperature T. Thermal equilibrium मतलब पार्टिकल जब हरकत कर रहा, ये वेव की शक्ल में जा रहा, नो डाउट, बट इट हैज द temperature T, then at that time that kinetic energy is given by, we know this equation, kinetic theory of gases में पढ़े हम, kinetic energy is equal to what? 3/2 क्या?
KT.
KT, where K is the Boltzmann constant, T is the absolute temperature, isn't it? And therefore, if I put this equation here, ये फार्मूले में अगर मैंने काइनेटिक एनर्जी की जगह पे ये रखा तो ऐसी बन जाएंगी क्या इक्वेशन? लैम्बडा इज इक्वल टू h अपॉन 3 √3 mkt. इज इट देयर? कैन यू अंडरस्टैंड? ये इक्वेशन से ये इसको नीचे लेना पड़ेगा, तो नीचे ऊपर 2 आएगा, 2 ऊपर जाएगा, 3 नीचे आएगा, अंडर रूट के अंदर kt होगा. कैन आई राइट दिस इक्वेशन लाइक दिस प्लीज? प्लीज यस और नो?
Yes, sir.
काय की एक्सप्रेशन है? प्लीज टेल मी नाउ फ्रॉम योरसेल्फ. आई वांट द आंसर. व्हाट इज लैम्बडा? प्लीज अनम्यूट ऑल ऑफ यू. व्हाट इज लैम्बडा?
Wavelength.
De Broglie wavelength.
इज इक्वल टू क्या? h, प्लैंक्स कांस्टेंट अंडर रूट 3m कांस्टेंट. व्हाट इज दिस kt? kb कांस्टेंट, बोल्ट्जमैन कांस्टेंट. व्हाट इज t?
Absolute temperature.
So can you tell that this is the expression for the de Broglie's wavelength in terms of
Temperature.
temperature?
Temperature.
Absolute.
The required expression where k is the Boltzmann constant, इसकी कीमत रहती 1.38 into 10⁻³ जूल पर किलो फॉर एन इलेक्ट्रॉन. अगर हम बोले अगर क्योंकि हरकत करने वाला इलेक्ट्रॉन था तो उसकी मास इज दिस वन. c electron 1.6 into v. All these things we knowing. When I put all these values in this particular equation, the value of lambda will come. Lambda is equal to 12.27 upon under root v into a. This is the required expression for it. So this is the expression for the de Broglie's wavelength in terms of energy as well as in terms of what? Temperature, isn't it? And now you know relativity also. सेकंड ईयर में रिलेटिविटी हो गया. we need to use the relativistic formula for the momentum. p is equals to क्या? mv. लेकिन v के जगह पे हम क्या लिखते हैं रिलेटिविटी में? m is equal to m0 into v under root 1 minus v square upon c square, where m0 is the rest mass of the electron. Therefore I can write this equation in this manner also. m0 into c, h upon v into this one. This is the required expression for the momentum of the de Broglie's wave when it is particle as well as in form of the wave. Have you understand this one? De Broglie hypothesis, have you understand? Please tell me yes or no. Unmute all of you. De Broglie's hypothesis समझ में आया?
Yes, sir.
De Broglie's wavelength समझ में आई?
Yes.
And can you obtain the expression for the de Broglie's wave in terms of temperature as well as in terms of energy?
Yes.
So if I conclude the lecture today, you found that if I summarize the today's lecture, then here I have explained the de Broglie's hypothesis that matter possesses particle as well as wave nature, isn't it? We have also derived the expression for the wavelength of the de Broglie's wave in terms of energy, that is kinetic energy, and in terms of temperature also. That means overall impression of this total today's lecture or content of the today's lecture is that according to the Louis de Broglie in 1924, matter possesses particle as well as wave nature, and all the concepts associated with the wave, that is wavelength, momentum of the particle, all these things are associated. When it is in form of the wave, it possesses the wavelength, and the wavelength is denoted by the symbol lambda, and the wavelength has the expression in terms of energy, kinetic energy. Also it possesses the value or expression in terms of temperature also. So with this one, we will stop here today. Thank you for joining me. If you are having any problem, please tell me as early as possible. If you are having any question, please tell me. Have you got? समझ में आया आपके? Have you got, please?
Yes, sir.
So may I stop here today? Please tell me. The remaining thing we shall see.